is Steve Austin. He is Field Operations Section Director at TxDOT. His section is responsible for administering the bridge inspection program in Texas, providing statewide policy and support in the areas of bridge construction and maintenance, and bridge preservation, scour, and I think the most important thing is spent 10 years in the private industry. He started in TxDOT 2014 and looks like he moved up pretty fast. So here's Steve.
Hello, everybody. Happy to be talking to you all today about experiences that we've had recently as we've introduced PPC to our toolbox. Graham Bettis yesterday mentioned that we learned about PPC at one of these Southeast Bridge Preservation Partnership meetings. And so this is really how we initiated effort to try it and to share with you the experience that we had on our first implementation project. I'll focus this discussion on one specific project, a project in the northeast part of Texas, where we had a series of 6 bridges with issues isolated to the deck. So substructure and superstructure were in good condition, and we were looking for a tool to add to our toolkit that would help us to provide a protection level to our bridge decks. So with increased focus on brine and de-icing chemicals across the state, trying to find something that we could add to protect our bridge decks was important and is important as ever. These bridges that we focused our efforts on were a series of 6 bridges over a 15-mile stretch of I20. All of these bridges cross over IH20, so we tried to take a measured approach to the risk, looking at rather than focusing on the interstate bridges themselves, looked at a series of bridges that went over the interstate. These were state loops, county roads, FMs, and a state highway, so we were looking as high as about 6,000 ADT, so not extremely high risk. All of the bridges, I'll run through the list of bridges, but all of the bridges on this project were constructed in 1965 or 1966, had 4 spans of pre-stressed beams, superstructure, and had about 260-foot span lengths. This first set of bridges was a pair, 281 southbound and Loop 281 northbound. Both had 7¼ inch bridge decks and 8-foot beam spacing. The decks on these bridges had a condition rating of 6. The riding surface was worn, I guess, worn down. The concrete was worn down. There were fine map cracks, some transverse cracks, a few spalls. The deck was polished, but again, the superstructure and the substructure were in good condition. So on one of these, we applied the 3/4 inch polyester polymer concrete overlay, and right away, right after the installation, the condition rating of the deck was raised to a 7. On the adjacent bridge, the northbound bridge, we applied a 2-inch concrete overlay. This has been our go-to for I'd say almost 50 years for applying, for providing a protection to our bridge decks. Because of cracking, shrinkage cracking, the condition rating of the deck stayed at a 6. So even though we know we've got maybe a level of protection, it didn't show in our numbers. So this is kind of related to a presentation or discussion that we had yesterday about quantifying the benefits of a preservation action. So in one, we had immediate benefit and quantifiable benefit if we're assigning a grade or a condition score to based on a condition rating. So maybe we bumped up the equivalent bridge deck score if we wanted to grade it on a A to C or A to D. Maybe we went from a C to a B, or a B to an A in this case. And so that's important, right? Making sure that we can quantify those benefits. In the case of the northbound bridge, staying at a 6 really means, well, maybe we prolong that condition rating of a 6 for a little longer, but it's hard to justify, it's hard to see from maybe administration's perspective, well, what's the benefit of doing this? So obviously, from that perspective, the PPC has a little bit of a benefit. The next bridge over was County Road 3110 over I-20. Similar to the last bridge in a lot of respects, this one had a 6.5-inch deck with 6-foot 8-inch beam spacing. It's got a 15-degree skew, so it has a little bit of issues at the joints that are a little bit of a challenge. The next one over, again, very similar, but this one's got a 6.5-inch deck, 6-foot 8-inch beam spacing, and we're talking about a 35-degree skew there. Next one over, 7.25-inch bridge deck with 8-foot beam spacing, and all of these generally have two lanes of roadway. Sorry, these last three that I'm talking about all have 3 lanes of roadway and have really common deck issues where we've got transverse cracks, fine map cracks, and we applied a PPC on all of these 3. Again, the deck surface had widespread minor cracking and a couple of issues where we had partial depth or maybe even full depth deck repairs. At the far east end of the project, we had State Highway 43 over IH20, and on this one we applied a concrete overlay. So this was kind of more the riskier one, even though it really only had 6,000 ADT or so. Going with what we knew, what we were familiar with at TxDOT, we went with concrete overlay, 2-inch concrete overlay. On that one, we were able to see an increase in the condition rating of the bridge. It went from a 6 to a 7. So there's benefits there, right? There are those quantifiable benefits that I was talking about. So how did we get there? Well, trying a new deck preservation strategy. We've talked about how something and we've learned that something in one state or one part of the country doesn't always translate to success in TxDOT or in Texas. We did outreach to industry, outreach to other states, and we saw that Caltrans has had 25, almost 30 years of success. North Carolina could do it, so why couldn't Texas do it? That was kind of the thought. So leading and interesting. We know sometimes, well, I guess I'll go through this table here. It just shows the price comparison of the concrete overlay on the project with hydro demolition surface prep that we believe provides a better surface preparation option for when we're applying a concrete overlay or latex concrete overlay compared to the PPC overlay with shot blasting surface prep. And you can see on this project, concrete overlay with hydro demolition came in at a whopping $59 per square yard, which is a steal for concrete and hydro demolition. This compares to $130 a square yard over the past 2 years, and it's gone up here recently, but on average over the last 2 years it's been $130 a square yard compared to PPC. On this project, that came in at $95 a square yard compared to the statewide average for the past 2 years of $110. It's been pretty stable at about $110 for 3/4-inch PPC. Here recently, we did try a 3-inch PPC overlay project due to address grading issues on a bridge, and that one came in almost twice that cost. I think we had obviously the increase in quantity, but then also the increase due to all of the material shortages that we're seeing. So thickness plays a big part in the cost for sure. Material costs are expensive for PPC. So just a little bit of overlay considerations, a little bit on overlay considerations. Concrete overlay, would say is used to strengthen bridge deck. Load rating of beams can be affected when we're adding substantial thickness, and really whenever we're adding even 3/4 of an inch of thickness, we should be updating our load rating, but the impacts would be more drastic once we're talking about any significant thickness in overlay. Obviously, there are issues related to rail retrofit if we're adding 2 inches of height to the riding surface, or and that effectively decreases the effective rail height. So rail retrofit may sometimes be necessary when we're talking about a thick overlay. And then when we've got a thick overlay, we need to transition back down transition back down quickly to minimize the approach roadway work. So we've got to taper down from that increased thickness. There's surface preparation options that need to be considered. I mentioned hydro demolition is our preference, but we've done concrete overlays on shot blast surfaces. And then finally, duration of work needs to be considered, and I'll go a little bit into discussion on that here in a second. Our concrete overlay is usually 2-inch, anything less, and you end up with problems with it being too thin. Our CO mix has as we call it, the concrete overlay mix, 0.4 max water to cement ratio, and here in the last several years, we've been pushing for steel fibers. On this project, we went with 50 pounds per cubic yard of steel fibers. That seems to give us a good quality. I'll still offer workability, maybe bordering on workability and not being able to work with it. And then finally, on this project, we went with a broom finish. As far as duration of work for the concrete overlay, surface preparation consisted of milled bridge decks, so that took a day per phase. Then hydro demolition on this project took as much as 5 days. There were some issues with equipment that posed problems, that posed challenges, equipment breakdown, so that added a little bit extra. But on average, it was about 5 days to do half of a bridge deck. Forming took several days. Pouring, that was done in 1 day, and then wet curing was 4 days. I mentioned that on one of the bridges we had pretty bad plastic shrinkage cracks. Our specifications require that cracks be sealed, and in this case, contractors were making an argument that well, the cracking is because the bridge deck is too flexible. Well, it's not. I don't think that's really the case. They're just simple pre-stressed concrete beams that aren't very long, but that got into a long discussion, and you're going to have that, right? I guess contractors will point at anything sometimes to explain why something's not working. So we had, unfortunately, that discussion took a whole lot longer than it should have, I think. In general, though, the overlay looked fine with the exception of the shrinkage cracks. One challenge at joints. The joints in the concrete overlay were holding up, but on one of the bridges there was an abutment back wall that came up to the riding surface, and that was just too narrow to maintain the joints on each side of that abutment back wall. So the contractor proposed to use polymer material for that narrow strip of what would have been maybe a thin concrete section that didn't have that same continuity that you've got away from the joints. Here are a few design considerations for determining if PPC is a good option on a bridge. The thin overlay option it's a thin overlay option that offers a durable protection, another increased barrier to chloride resistance. PPC offers skid resistance, high skid resistance, and again, additional barrier for the reinforcing. PPC on installation on this project, work was performed in March and April. The contractor, I guess, decided to cleverly set up all of the traffic signs and cover those that were not applicable, and then uncover them as work was progressing. And so that worked really well. And the team was able, it was a specialized team that came in to do the work. The shot blasting, vacuuming, and PPC application were done in 1 day per side. So it was, hey, knock one out, uncover the signs. After 4 hours, you can open up that stretch to traffic, or that segment that had been completed to traffic. Yeah, I mentioned a specialty team. They knew how to activate the product, work, and then reactivate the material. Here are a few photos of the equipment and installation. The fact that it was just a 3/4 inch thick layer really made it to where there wasn't a whole lot of setup or form work that was required for this. And then here's broadcasting of the aggregate for that high friction desirable surface. Overall, the performance was very good. There were some spalling and delaminations at the joints that were after reaching out to the vendor. They were addressed by the specialty team. They went back out there, focused on those locations, and addressed the joint issues. We had a good relationship with the vendor through this partnership too, so that helped, I think, too, to say, hey, we need your help out there to help resolve the issue. So here a few things to keep an eye out for on projects. Joints are the most important and probably the most challenging part on a PPC project. And on our project, the joints weren't beveled, so they had to come back and grind them. Material was sometimes placed across the joint. And so it's a critical issue to make sure that the timing of the relief joints is done within 2 hours. Otherwise, you get expansion that starts to play. So our preference, and we're incorporating this into our standard specs as we move forward, is to use a form at the end rather than saw cut the joints, because there's the setup and that 2 hours for the product before the relief joints needs to be cut. It can sometimes vary depending on temperature, and so a really hot day, you might get the product set a little sooner. So in general, TxDOT has had success with both overlay types that I talked about today. There seems to be less risk in polymer overlays once we've got that specialty installation crew. PPC may offer an economical solution when deck strength is okay, but it doesn't offer the same benefits that concrete's overlay would provide for increasing capacity of a bridge deck. PPC can be installed very quickly. We saw that on this project, and really pay special attention to joints. PPC overlay had fewer issues on this project. The trial was a success, and we've implemented PPC on 11 projects for a total of 35,000 square yards in the last 2 years. We'll be incorporating PPC into our standard specs, and one of the challenges with that I was talking with the folks in North Carolina just yesterday about is how to do this sampling and testing. Once things go into standard specs, trying to find a way to make sure that we're getting the product installed as we roll out to what will probably be 10 times that quantity per year ultimately. We think that adding this to our toolbox and our measured approach to the trial application was good. That's about it on what I was hoping to talk about for the project. I did want to share, I'm on the National Bridge Deck Working Group for Deck Preservation Working Group. One of our deliverables, or one of our big accomplishments for this past year was creating a bridge deck preservation resource guide. This is available on TSP2. This is supposed to be an unbiased, objective approach to evaluating bridge deck preservation options. There was discussion yesterday about, hey, how long does something necessarily last? And we've tried to pull from a number of resources to add how long something might last, or something should last based on other resources. So this is probably a good resource. If you're not familiar with it, I'd encourage you to visit the TSP2 website and take a look at it. It's only a few pages, and the intent was to kind of keep it all condensed.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.